Hello, welcome to Technoveda Solutions.
In this video, we'll discuss about how the function work and what are the different types of functions in the programming, which will be used in both C as well as C++ programming. Now, starting with, already we know that the functions are the modules of a code that can be tested independently for its functionality or operation. Any block of the code should be made as a function if it can be tested independently and it is reused. Then we will make a function for that particular operation, and we can use it whenever we require that particular operation. We used to call the function. Okay, so in the function we have basically two parts. One is a declaration part, another is a definition part. Now in most of normal C compilers, we can directly declare the function and define at the beginning of the program itself, or we can declare the function after the main function also. In normal C compilers it is allowed, or C++ compilers. But when we go to embedded C compilers or cross compilers, if you want to define a function after the main function, then it requires a function prototyping. This, what you can see here, the syntax, this itself is a function prototyping, wherein we will mention the return data type, function name, and list of parameters with semicolon as a termination. This is in the prototyping. Remember, if we want to define a function, here you can see in the example, if I define the function, then I will mention the return data type, then function name, then parameters, then there will not be any semicolon, rather we start with the body. So here this is a declaration, the body or the implementation of the operation is definition of the function. So function will have declaration part and definition part. And if you want to go for embedded C programming, then prototyping is made compulsory. However, if we go for a strictly C compilers, there also prototyping is compulsory. But most of the C programs we write in the C++ compiler. So in the C++ compiler, prototyping is not mandatory. But in embedded programming, it is mandatory if we are defining the function after main. Remember, without prototyping, we can declare and define there itself before the main function. But if you want to define the function later, then we need to have a prototyping before the main function in the embedded C compilers. Now, how does a function execute? So there will be basically a two part. One is a calling function part, another one is called function part. So in any operation of the functions, we will have two programs or two functions. One is a calling function, another one is a called function. In the calling function, say let's it's a main function which is a calling function. Here in the function we write certain statements and we call the function here. Okay, now when we call the function, the control goes to a function which is called, but we know that after execution of this called function, it should return back to the next statement after calling the function. Now, how does a control knows where to return? So it should have some directions. So what it does is, just before going to a called function, it will store the status of calling function. Now status will include storage of the PC and PSW. So PC is nothing but a program counter. This register, that is program counter, will have the address of next instruction to be executed. So while coming back, it will come back to this address which is pointed by program counter, so that it will know where to come back. So always PC will store the next instruction to be executed. So just before going to the called function, system saves this program counter in the stack memory. Along with that, it also stores PSW, that is program status word. Again, uh, for your information, there can be in some controllers it will be PSW, in some of the controllers or the processor it will be SR. It depends on the architecture. So PSW is program status word, and there can be a, in some context in the risk architecture we call it as a SR, that is status register. Okay, usually in CISC it is referred as PSW, in RISC it is referred as SR, status register. Now these two are stored in the stack memory before going to a called function. However, if programmer wants, then he can store additional variables or a data also in the stack using a push instruction. This is instructions to write to the stack or push to the stack. Once we store all the data required in the stack, then the control goes to a called function. Then it will execute a called function. After completing the execution, this return statement will indicate it has to come back to the calling function. Now, while coming back, it has to read all the data what we have stored while going to the function. That is called pop operation. Push operation is to write into the stack. Pop operation is to read from the stack. Remember, the last value what we have stored will be read first. That means it will be a last in first out algorithm in the stack operations. Always remember that. One more important thing is, now we said that when the function is called here, the control should go to this calling function, called function. Now how does it know where the called function is stored? So the function name itself acts as a pointer to the memory location where the function is available. So this function name is an implicit pointer. When we are discussing the pointer, again I will come back to this point. Okay. Now this push and pop operations, what we do, that is writing to the stack and reading from the stack, those two operations together is called as a context switching. And remember, this will take a certain finite amount of time, that is called context switching time. So this context switching time is going to be an overhead in the function. More the function call we have, more the time we spend on the context switching. So we should always make sure that context switching is as minimum as possible in the implementation. That care should be taken. So what function has to be implemented, that should be very carefully done, because if the function is taking lesser time than the context switching, then there is no meaning why that particular section of the code or a block of the code should be defined in function, unless it is not mandatory to do so. Okay, then next we will see the advantages of having the function in the program. First thing what we get is modularization. Then as we have a modularization, it will be easy to understand the program. It can be easy to reuse that particular code. The legacy can be understood very easily by the further programmers, which is very important in real-time application development, because most of the time we'll be using a legacy code and we will be modifying and developing a new code based on that. Every time it is not necessary that we always start from the scratch. We may not. So modularization becomes very important. So that reduces redundancy. We need not define the same operation multiple times in the program. We can define a particular operation as a function and we can keep calling it wherever we want. So that will reduce redundancy of coding. So because of reusability and abstraction. So it will available for multiple users. We can call it any number of times. So that code becomes reusable code. And without knowing the implementation also, we can use some functions. For example, in the C program we use printf, scanf. These are the very common functions what we use, but we don't know how exactly it works. We have not seen the definition of that function, but still we are using. That means that's a abstraction. Without knowing the implementation, we are interfacing with the code. Then flexibility is provided to update and test. So we need not run the test for the entire code, only for that function which we update. Test can be run only on that code, so it will be faster and easy for debugging also. If there are any issues, we can easily identify if it is a modular. Otherwise, entire code has to be checked again. Instead of that, that particular function can be checked and tested and debugged. Of course, last one is it improves the readability and understanding of the code. These are the advantages of having a function. but there are certain limitations and disadvantages also. Depth of nesting in case of functions is limited by stack memory. As we know that every time the function is called, a certain amount of memory is consumed from the stack. So stack memory size what we have, that will limit how much depth we can nest the functions, how many nesting can be done one inside the other. It is sometimes referred as a level of nesting or depth of nesting. Especially it's very important when we go for recursive functions and multiple nestings. That time we should take care how that it will not overflow the stack. Theoretically there is no limit how much we can nest, but practically stack memory size will limit us the level of nesting or depth of nesting. One more limitation is functions cannot return multiple values. Only one values can be returned from the function. We cannot return multiple values directly. Execution timing overhead due to context switching. Already I told you that for context switching it will take certain amount of time, and that will be an overhead for the execution of the code. These are the limitations and disadvantages of using functions. Now we will see what are the different types of function. The first one is regular function, what we usually use. Then we have recursive functions, inline functions, reentrant functions, and pointer functions. These are the different types of functions. Let's understand one by one. Regular functions we are already just now we discussed, so directly we'll go to recursive function. The function which is calling itself are referred or called as recursive functions. And these recursive functions are very much helpful when we develop data structures like tree, graph. To traverse through the graph or a tree from one node to another node, we can use a recursive function to meet the condition. So always recursive function should converge towards the terminal condition. There should be an end for the recursion. It should not be an infinite recursive. Otherwise, you always will get a stack overflow as a runtime error if we don't take care of terminal condition. So this is how we implement it in recursion. That are given just name as recursion. It is not a keyword. You can give any function name. Then we are passing the parameters, and here you can see we are calling the recursion function itself. The same function we are calling here. Whatever the function name we give, the same function is called here. Again, I am repeating, this word recursion is not a keyword. It is just a function name. So here is a terminal condition, that is once x becomes 0, it will return. It will start coming out of the function blocks. It returns to the first called function and then to the calling function. Then the next type is inline functions. So inline functions are used to avoid the context switching. Now we want a certain properties of the functions, but at the same time we want to avoid the context switching. Then we use inline functions. So it will give us advantages of function without adding the context switching overhead. So for that we use a inline keyword. Now when the function is defined with inline keyword, whatever the code we write, entire code is copied to all the location wherever the function is called. The entire function is inserted at calling place or the calling location. Okay, so here in the execution we will have a entire function in the one executable program or the function itself. Then in inline functions, if there are certain conditions, then inline is not considered by the compiler, or compiler will ignore it under certain conditions. First one, if the function contains a loop, then inline, even if we write an inline, compiler ignores it. It will not consider those function as an inline function. If we have any static variable defined in the function, then that function cannot be an inline. If the function is recursive, it cannot be inline. If the function has switch or go to statements, then also inline cannot be used. Switch is a control structure which we already have discussed. Go to is one pointer, or it is used to directly go from one instruction to another instruction. But most of the programming models try to avoid using go to instruction. Okay, then we have if the return type is other than void and it doesn't have a return instruction, then also inline keyword is ignored. Remember, even if we define the function, if it is not meeting these conditions, then that function will not be made inline by the compiler. So next type of function is reentrant function. Now these functions are used to service the interrupts. Okay, so whenever we want to have an interrupt programming, we will be making such functions as a reentrant function. So in reentrant function, we are not supposed to have global or a static variables, because reentrants are basically used by multiple functions simultaneously, or multiple programs will be calling that functions simultaneously. So that function should not have any global variable or the static variables. Otherwise, it may lead to data inconsistency. It may happen so that there's a program 1, there's a program 2. Program 1 is calling the function which is reentrant. For example, we have one resource, say we have a resource like a timer, or we can say one IO port. Program 1 is using that IO port. At the same time, program 2 comes, which is being executed now because it's a higher priority, so that is scheduled. And that program 2 also uses the IO port, and but as this IO port is defined as a reentrant, it can be again used by another program also. But if there is a global variable, then that data inconsistency can happen in such situations. So global and static are avoided. And reentrants should not call any other reentrant functions. Reentrant function can call other reentrants, but it cannot call another non-reentrant functions. Okay, these are the conditions to define the reentrants. Then we have a last type, that is a pointer function. These are the function which either has a pointer as a return data type or as a parameters. Remember, these are pointer functions, not, I repeat, not function pointers. They are different. Pointer functions are the functions using pointers as an argument or the return data type. Function pointers are again comes under pointer. We will discuss that. But here, pointer functions are the functions which uses pointers as an argument or a return data type. Okay, so these are different type of the functions. Hope you've liked the video. Please click on the like button. Please subscribe to the channel and share with the friends. Thank you. Have a good day.